and welcome to this lecture of Project Quality Control Process. Now, my name is Dr. Ahmad Huzaimi from University of Malaysia Pahang Sultan Abdullah, and today we will be exploring the mechanisms and tools used in controlling quality in projects as the part of broader field of project quality management. Now, whether you are involved in the construction of high-rise buildings, deploying a cloud-based IT solutions, or managing an automated manufacturing process, maintaining quality throughout the project life cycles is vital. Quality control ensures that what is being produced or delivered actually meets the intended quality requirements defined during the planning phase. Now let us dive into how this happens and why it matters in the real-world project settings. Now, understanding quality control, the basics. So the quality control is a managerial process aimed at ensuring operations remain stable and that the deliverables are consistent with project expectations. It helps to prevent adverse changes, detect deviations early, and take corrective actions when things go off course. So there are three key functions of quality control in project management. The first one is evaluate actual performance of deliverables or processes. Second, compare actual performance to quality goals of standards. And the third one, to take corrective actions to eliminate the root cause of any discrepancies. For example, imagine you are overseeing a highway construction project. If the asphalt mixture fails to meet temperature specifications during applications, the quality team would identify this deviation, compare it to standards, and direct the crew to reheat or remix the asphalts to ensure proper bonding and durability. Now in IT, suppose you are deploying a mobile banking apps and discover bugs in the logging feature during user testing. The quality control kicks to log to defect, initiate code revisions, and verify that the fix aligns with securities and user experience standards. Now let us delve the Juren trilogy, the framework for quality management. Dr. Joseph Juren, a leading figure in quality management, proposed a structured approach called the Juren trilogy, which consists of quality planning, quality control, and quality improvement in project settings. The quality planning happens during project initiation and planning. For example, when planning a food processing plant, engineers define the tolerances for production equipment and packaging processes. Now, quality controls involve monitoring to ensure these plans are being followed. Now, inspectors might sample output regularly to test if weight and sealing standards are being met. Quality improvement focuses on identifying gaps and enhancing future performance. So these could involve investing in automated inspection machines to reduce manual errors over time. So the trilogy helps ensure not just one-time quality, but sustainable excellence throughout and beyond the project life cycles. A quality control versus quality assurance. So this is a common understanding. Now, often confused quality control, QC, and quality assurance, QA, that serve different but complementary functions. Quality assurance is process-oriented. It ensures that the methods and procedures used to deliver the product or service are sound. QA is proactive. Quality control is product-oriented, so it checks whether the actual outputs meet quality standards. So QC is reactive. Now let us apply this to a project context in a hospital construction projects. Now the QA might involve ensuring that all construction follows ISO 9001 standards, so such as maintaining calibrated tools and approved construction methodologies. Now QC is, in contrast, might include testing the fire resistant rating of installed doors to verify they meet safety requirements. Now in IT, QA ensures developers to follow coding guidelines and conduct peer reviews. The QC checks the actual functionality during system testing, such as validating that data entry fields don't accept invalid formats. Now together, QA and QC ensure the project is both done right and produces the right results. Now let us look into the feedback loop, a core principle in quality control. Now at the heart of quality control is the feedback loop, a closed cycle of monitoring, comparison, and action. So these loops include four major components. The first one is sensors, detect what's happening. Second, comparators, They evaluate whether this is acceptable. Now, third is actuators, the trigger changes if needed. And the fourth one is controllers oversee the entire system. Let us use a construction example. During high-rise building works, laser scanners and sensors measure wall alignments. So the comparator checks this against the blueprints. If misalignments exceeds, tolerance actuators trigger immediate reactification, such as replastering or realignment. So in IT projects, user behavior tracking tools serve as sensors. So if data shows a drop in engagement due to show loading times, the comparator flags it and developers act to optimize scripts or server performance. So this cycle ensures that real-time feedback leads to timely interventions, the hallmark of an effective quality control system. Now, self-control is actually encouraging accountability on the ground. Now, another important concept is self-control, the ability of project team members to control their own quality outputs without direct supervisions. So this promotes ownership, accountability, and efficiency. Now, in lean manufacturing environments, operators may stop the production line if they detect a defect. This is known as JIDOKA in the Toyota production system. So in a project setting, let us consider a civil engineer responsibility for concrete pouring. If he or she notices the slump test fails before pouring begins, she should have halt the process and request adjustments rather than relying on quality inspectors to catch it later. In IT projects, developers might write and run unit tests before integrating new features into code base. So this reduces bugs and accelerates downstream testing. The safe control creates a culture of quality at its source of empowering people to be proactive instead of reactive. The PDCA cycle, or plan, do, check, and act. So the PDCA cycle, also called the Deming wheel or Shewhart. So cycle is a powerful continuous improvement framework. The first one is that plan, identify quality issues and plan improvement actions. The do, implement the plan, check to monitor the results, and act to standardize the success of adjust the approach. Now let us apply this to a software development project. For the plan, a module is designed to improve user login speed. Do, the development team codes and deploys the update. Check, testers measure login times and post-deployment. Act, if performance improves, the update is standardized. If not, further action is taken. So in construction, this cycle could be used to improve site cleanliness, which affects safety and workflow. A plan is drawn, bins are relocated for convenience. Outcomes are observed over 2 weeks, that is checked, and adjustments are made, that is act. Now, PDCA cycle ensures that lessons learned lead to operational improvement. Now, the pyramid of control in organizations. The pyramid of control shows how quality is managed across organizational levels. At the base are automatic controls, monitor tasks using sensors or software. So the workforce uses SOPs and checklists to ensure processes compliance. Supervisors and middle managers intervene when deviations persist. Senior management sets quality policy and culture. So in a construction projects, the pyramid might look like this. The drones and GPS mapping automatic controls, and the site workers following inspection checklists, that is workforce, and the project managers reviewing weekly dashboards. Now, directors deciding to invest in building information modeling or BIM technology for long-term improvement. So this layered control ensures that each level has a role in protecting quality. Now, planning for quality control. The rules and tools planning for quality control ensures that everyone knows what is expected and how quality will be monitored. So these involve identifying quality standards such as ISO client specs, so defining key control points in the process, assigning responsibilities to individuals and teams. In the factory setting, the QA department might define control points after packaging to check the sealing, barcoding, and weight. In IT, this might include source code, review, performance testing, and user acceptance testing. Who is involved in planning quality control? So staff quality specialists creates the control strategies. Department heads and supervisor ensures a frontline executions. The multifunctional teams assess customer needs and process alignments. So these collaborative plannings enable organization to bridge the gap between customers' expectations and daily operational realities. The flow diagrams and control stations, visualizing and localizing quality. To make quality control more practical and visible, we use tools such as flow diagram and control stations. A flow diagram helps map out every step of a process, highlighting where quality checks should be implemented. So in manufacturing, a flow diagram for assembling a TV might show incoming inspection, the PCB installation, wiring panel, fitting, and final testing. The control stations are then placed at critical points like right after wiring and just before packaging to check functional defects. In a construction project, a flow diagram of formwork installation could identify points where alignment and anchoring should be verified. So these become a control stations for engineers. Now these visual tools make it easier to pinpoint where quality is at risk and empower teams to act. To wrap up, quality control is not a single activity, but it is a systematic approach involving a feedback, self-management, and structured planning, and continuous improvement. Let us summarize. So it ensures that actual performance aligns with quality goals. It uses the tools like PDCA, flow diagrams, and control stations, and it empowers everyone from operators to top managers to participate in quality protection. And it directly affects the project success, client satisfaction, and long-term organizational reputation. Now, as project professionals, your ability to design, implement, and lead quality control processes will directly influence how well your projects deliver value. Thank you for joining me today. In the next session, we will examine how quality control processes are documented and integrated into the overall project quality management plan. Until then, I encourage you to reflect on how these concepts apply in your own professional context, whether in the field, at your desk, or in the lab. Thank you.